Okay, hello everyone. I think we are live. So welcome to another episode of the AI workshop, AI workshop number 8. We are here with Danilo. Hi, Danny. How are
Hello.
you?
Good.
So Danny is a member of the AI team. He's a full stack developer working in Lenio. How many years, Danny, that we have you?
2 years, I think. No, two and a
Okay,
half.
so okay, he and I we have been working on knowledge graphs and LLMs, and basically Danny is going to lead this talk and show us what have you done, Danny. Let's go with the agenda for today.
Okay, awesome. So, hi everyone. Today we are going to discuss about what are knowledge graphs, why knowledge graphs with LLMs, RAGs architecture, graph databases, especially Neo4j for today, and what are we building, which is a POC showcasing all of these technologies and concepts. Okay, what are knowledge graphs? Knowledge graphs are a way of organizing and storing data um, that allow us to represent information in a graph structure, basically. They are databases that use graph
Sorry, Danny.
structures. Yes.
Can you
Mhm.
share the screen? I think there is not. I don't know.
Okay, okay. Um, it shows to me that is live, I think.
Um,
Um, a screenshot. Um, okay, let me try again. Can you see it now?
um, I expecting the
Okay, we have the confirmation.
yes.
Nice,
Okay.
nice, nice. Sorry. Okay, so knowledge graphs are a way of storing data in a graph way with nodes, which are our entities or concepts that we want to store, the relationships between those entities, and properties which are for giving more information about those entities or those relationships. Why knowledge graphs with LLMs? Basically, we have two big issues when using or building LLM apps, which are the knowledge cutoff. Uh, that is a way to say that the LLM is unaware of any event that happened after the training, or that the LLM wasn't trained with our domain specific or private data. The other problem is that we have that uh, LLMs are trained to produce realistic sounding text, which is not always accurate. So using knowledge graph with LLMs is a way of providing our own unstructured data in an structured way, which is useful for representing complex interconnections and relationships between the entities that we could have in a more visual way and a machine readable way. Um, Here we have kind of pros and cons of mixing knowledge graphs and LLMs. Basically, we are filling the gaps between each other. Um, I don't know if you have any insights on that, Facu.
No, basically, it's a reinforcement on what you said. Basically, the knowledge graphs are the pros are the structural form, and they are accurate in the way that you could search something and the output will be the same. Whereas the large language models in nature they are stochastic, so and they hallucinate a lot. Also, the interpretability on the or the readability of the knowledge graph is super well defined, whereas the LLMs they are kind of a black box. So basically, yeah, these two things we could take the best of both worlds and combine it, right? So
Yeah, awesome. So following up, we have the racks, which, as we previously discussed on some Lenius AI workshops, are first stands for retrieval augmented generation, which is a method that allow us to use better or more specific information uh, and improve our retrieval on the text generator components of the apps we are using. So in this way, we could use more knowledge intensive tasks on the LLMs. Basically, the architecture is like this image. First, we have a question that could that the user could give. We have a smart retriever that today we are going to be using LangChain. That smart retriever search on our knowledge base, which today is a graph knowledge base, and then we parse that or transform that answer into natural language to return it to the user or to the source that we asked. Uh, then we have the graph databases that today we are going to be using Neo4j. It's a way of storing nodes instead of tables. It's a known SQL database. We could store nodes, properties, and relationships in a kind of a whiteboard like format, because we could, as I'm going to show, we could draw those entities on or the nodes on our schema and connect them between with relationships. Uh, we also have a language to query those databases that is called Cypher. Here we have two small examples. On the first one, we are saying that, okay, give me the entity person where the name is Tom Hanks. And on the second one, we have give me the person entity that is connected to the movie entity through the directed relationship. Then we return that movie title.
I have
Okay.
a question, Danny.
Yeah, sure.
Maybe is there any advantage of using a graph database instead of I don't know, Postgres or in another database to store the nodes and
Mhm.
links? Why graph databases?
Okay, basically, as any tech or tech stack decision that we are going to use, we first need to look our use cases. Graph databases are especially useful for data that is highly connected. For example, you are building, I don't know, like a social network where you can have users and followers and followees uh, that is maybe too data expensive to a traditional or an SQL database. That scenario could be an awesome use case for the graph databases. And also we can query the data in a really fast way because we are using graph theories, and we could explore all the possible relationships between the nodes in a really fast way. That would be, I think,
Nice,
the main advantage.
nice. Thank you.
Okay, today we are building this RAG architecture where we have a chat UI in which the user can ask for questions about our dataset. Uh, this chat UI will call the LangChain agent, which is a way to orchestrate the usage of these tools that we have here. These tools are meant to, the search tool is to retrieve information from Neo4j, and then this, this search tool will translate natural language question into Cypher queries, and then it will retrieve it back to the user. Or we have this other tool that is the Cypher tool. Um, this one will receive, for example, an affirmation, let's say, from the user. For example, add this specific node to the schema, and that will convert it into a Cypher query and call the update DB tool to automatically fill or update the Neo4j schema. Okay, moving on to the POC. We are going to be using Neo4j. For anyone that wants to try it out, you first have to create a user account on Neo4j Aura, which is their management system. We have a free tier where we can use 200K nodes and 400K relationships, which is perfect for any small or medium POC or MVP. Then we can use the Explorer, where we can input some data. Neo4j reads CSV format and other common data formats. For this demo, I will be using a Star Wars dataset. I'll upload uh, three files: characters, planets, and CSV, which have a bunch of Star Wars information. Basically, we have to create the schema that we want to use. For example, let's say we add a node here, and then we call this node characters. We select the file from where we want to import the data. This is to fill the attributes. We are going to select all. Then we select which one will be the ID for that entity. Now let's create another one that could be, for example, planets. The same thing with the planets file. We map the attributes and we select the ID. And then we want to create the relationship that connects these two nodes. That could be, for example, as I have on this one, from. We select the file from where we want to map the relationship. This case is characters. We select the ID on characters, and we want to map it to the home world, which is here. Basically, we are saying, okay, these characters are from this planet. We can also preview that relationship, the node that relationship will generate. Which we have here, for example, all these nodes and relationships. For example, let's say we have the planet Nabu, and I don't know, R2D2, Palpatine, and other characters are from Nabu. And the same with the other planets and the other um, characters.
A question, Danny.
Yes.
The CSV. What is the
Mhm.
data inside the CSV? Could
Okay,
you show
let me
us?
show. Yes, sure. Um, Basically, okay, let me change the.
But basically, that contains
Oh,
all that
okay.
information. The
Yes, it's a bunch of
name.
rows with
Okay.
these properties. Mhm. Yes.
Okay. Okay. Nice.
Okay. Then once we have this for the demo, I did upload this already. We can run import, and then we can go to the tab, to the Explore tab. Um, and here we can see all of the nodes that we have generated inside our Neo4j store.
I have a
Um,
question, Danny, from the
mhm,
audience.
yeah, sure.
Is there a library to do all this using code, or you have to do it?
Y- Yes, we have uh, kind of uh, a lot because we could use a LangChain, as I'm going to show it in a second. I think we can also use Llama index to get this automatically. And we also can use, I think, any language, let's say Python or JavaScript or anything to uh, try to convert the files into the schema that we need here.
Nice.
Okay, this is the chat UI that we are going to use. Basically, we have a really simple chat built with all of this is built with React, and then we added here a little graph visualization tool to get a faster insight on what we are querying. Here we have the same as we saw on Neo4j. Let's say human here, and we have all the characters that are human, for example, all those relationships.
Beautiful.
Uh, for our backend, we are using a Google Colab notebook where we want to first obviously install the libraries that we need. I'll share this later. We are using mostly Fast API to build REST API and some endpoints, and LangChain, which is going to be our main orchestrator in all of this. Then we are importing some API keys and passwords that we need to connect to Neo4j or use the OpenAI API. We instantiate the graph using this Neo4j library. Then we instantiate also our GPT-4 instance to use it on LangChain. And then we have the part of the tools. As I said, we have three tools. One is to query the database and get the info that we have here, that we have there. Sorry. For this, we need to do some kind of prompt engineering where we are trying to um, we want that this tool use an LLM to convert the natural language question into a cipher query. For that, we kind of give an example here. How many streamers are from Norway will result on this cipher query. And then we use that prompt into our tool, which will be using the LLM that we instantiate above. We also are going to be sending the Neo4j graph, which contains the schema and all of this data. And then we have the second and the third tool, which are the most sensitive, let's say, because it's really hard work to translate schema updates from natural language to uh, cipher queries. But basically, we are saying that, okay, you, the LLM, are a data scientist that is going to try to translate user affirmations into cipher update queries. Then we are doing the same as above, but for another tool. And finally, we have the update DB tool, which is just for connecting the query that we get from here into Neo4j. This is all that this tool does. We create a list of those tools. We also set up a memory to to give our LLM context, and then we instantiate our agent. The agent will receive the tools and the OpenAI instance, and a bunch of parameters uh, that will improve its performance. Then finally, we set up a fast API app to expose the chat endpoint that we need, where we are going to send the agent app run method that will receive the tools and the input from the user. And then we just return some graph schema to display it on here. Okay, so to have it to showcase something, let's say I want to know from, I think this is the species. Okay, so let's say we want to know what species is R2D2. This will be sent to the Google Colab, and you can see here that that natural language query, what species R2D2, is being translated into a cipher query, which is this one. If we copy and paste this same query on the Neo4j Explorer, we could get this, the same thing as we are going to get on the chat. R2D2 is a droid.
Nice.
Okay. Also, we could ask, I don't know, for example, let me think on any question. We could have, what planet is he from? Remember that this keep the context of our previous questions. So it knows that we are talking about R2D2, and they say that R2D2 is from the planet Nav. Okay, we can also run some questions about, we could say like a count query, for example. We could do something like how many characters uh, are from the human species. And we can see that that will be translated into a count query here. So we have 35 characters are from the human species. We also can perform some queries about our entities attributes that, for example, we have here. That we have the character Luke Skywalker, and these are his attributes. We could, for example, say what is Luke Skywalker height, and this will have to give us, I think, 172. Okay, awesome. And just like as a final query, we could use the this part of the tool, the cipher tool, to update our schema. We could say, for example, add the character from another saga, let's say called Bart Simpson.
What are you doing? No.
Let's just imagine that Bart Simpson is on Star Wars. Okay, this we call the cipher query, which is this one. This could take a little bit, but basically it's going to try to convert this to a cipher query to update the database. You can see here, create Bart characters, name Bart Simpson. We could also get this. We should see that that entity was added. Sorry. Uh, return Bart. Okay, awesome. That is now on our Neo4j schema. Maybe we could see that here, but it's kind of hard looking.
Lonely without
Yeah,
connection. That dot.
we have March. Oh, okay. Let's imagine that is
One
any
of them.
here. Yeah, yeah. But yeah, that is basically uh, what we can do. Is really a powerful tool. Um, we can easily ignore the cipher and the updated tool and use the search for retrieval. And it's important to mention that if we have more data on our knowledge base, the queries and the information retrieval will be also better. But I think this is really useful if we want to provide our custom LLM with a specific knowledge base or confidential data that our, for example, business use. But yeah, I think
Beautiful, beautiful, Danny. Maybe there could be some queries to
mhm.
the knowledge graph from the audience. I don't know.
Mhm.
The I only know Chewbacca. I'm not I'm not a big fan of Star Wars, but maybe the numerous audience, the 10 viewers. Okay,
Okay.
but and a question, Danny.
Yes, sure.
The way that you generate the knowledge graph was with the CSV, right?
Yes.
But there is a way to link all together and to automate also the creation. For example, you have a text and you
Mhm.
want to extract all that in a structured way, maybe a table, a CSV.
Mhm.
Is there any like pipeline that you could use to do it like automatically, or
Yes, yes, we can. We just need to improve this pipeline, let's say. Here we could add some processes that first extract our data. It's not, we can use a large text corpus. We don't even need CSV files. And then we extract those entities, and once we have those entities, we know that those will be translated into nodes. But yes, we can do that definitely. It's one of the main uses of knowledge graphs.
nice? Um,
Here I want to show something that happens, and I read in many articles and from people that is building similar solutions. Note here that I have the tattoo implanted, right? But I wrote it with double T and with just a single L. But if we correct that like that, that will work. One of the biggest issues of knowledge graph retrieval, and I think most RAGs, is the ambiguity information, and also the spelling is you have to work kind of a lot to solve those things because now we have the maybe you could add something like I don't know, a dictionary to solve those issues. But yeah.
Yeah, maybe we could add like a vector DB with
Mhm.
embeddings to have that the opportunity to link maybe when you have a misspelling or when you put a connection that is a similar word but is not quite the same.
Mhm.
Maybe you could use embeddings to to search what is the best link or the best node that you could retrieve, right? Could
Yes.
be
Mhm.
because I worked with Llama Index, and they
Mhm.
have a combination or they called an hybrid type of search of
Mhm.
that they
Mhm.
use RAGs with a knowledge graph and also with a vector database. But they
Yes.
are not doing that in the sense that they are going through the links and search with the embedded links. They are not doing that. They just have two ways of retrieving information. One is the knowledge graph, and the other one is the vector database.
Mhm. Mhm.
But I think that could be an improvement on the knowledge graphs.
Yes. The one of the powerful things is that we could think of this knowledge base as a black box, and we could have here as many DBs or as many processes that we want, basically.
Hmm,
But yeah.
nice. We have some questions from the audience. Where is Shasha being from? Sorry if I'm saying that wrong.
Okay. Accordingly to our database, it's from the planet Nabu. I don't know if we is it's kind of hard to know that, but let's trust.
Yeah. Also, another question: can you have several links between two nodes?
Yes, we can. And also one of the things that we could have is to provide attributes or properties the to the relationships or the nodes to improve the information on them. But yes,
Nice.
we definitely can.
Nice. Um, so I don't know. Is um, do you see any other implementations for this? Or mm,
Um, I don't know, like the traditional use, just like a simple database, as I said, on, I don't know, like social network apps. But I think if you really improve your pipeline to have these issues solved, it could you could rely on this data, and you could expand the context of your LLM. But yeah, I think those are the main um, use cases.
nice. And in terms of the creation of the nodes and links itself,
Mhm.
uh, I don't know. Do you have any insights on that on how maybe how could we improve that or because we could use the LLM to
Mhm.
generate the links and nodes,
Mhm.
but I don't know. Do you have any insights on that? Um,
Um, Not really. It's I think one of the pros of using knowledge graph is that you have a really nice visual representation that you may not have on traditional databases or even on vector DBs. Um, but I think this is really good because you can debug the results of your generation queries. You can see where the nodes or the relationships are being generated. Um, but yeah, I think it's more like a data cleanup work or just trusting on the LLM.
okay. Yeah, it's a difficult task.
Yes.
It's of course. Um, okay, let me check if there is some other questions from the
Okay.
audience,
Mhm.
or we wanted just to see the UI and they look like a
Yes, this
swordfish.
is really cool. Yeah, but yeah. It's, I think, one of the best things that LLMs give us is a way of building these things faster, because this, uh, in my point of view, this is a cool POC that you can build on, I don't know, 1 hour or so. Um, it's cool to test ideas, and it's not that hard because you only have to kind of tweak the prompt that you are using.
Yeah, I think that like the reborn of the knowledge graphs
Mhm,
uh, came from the LLMs, and the
mhm,
way to generate them automatically. Like after we had another methods, like for example using spacity for entity recognitions
mhm,
and trying to identify the links with also another entity or something like that.
mhm.
And I think the way that we could build now the links and nodes with the LLMs is much faster. And if you are a really good prompt engineer and with a lot of patience, you could have a really nice knowledge graph.
Yes,
Um,
definitely.
yeah. Also, um, I want to mention like um, this is again to improve the output from an LLM, right? It's a
Yes.
RAG method,
Mhm,
and there are some new research that mentioned that if you have more than one retrieval method, for example, you could combine a knowledge graph with a vector database with a bag of words
mhm,
or some kind of that retriever, and you are
mhm.
going to basically attack differently the problem, because maybe uh, maybe you with the vector database you are very good at that at finding similar knowledge articles when and using different wording that the words that are present in the knowledge article, right? Because
Yes.
the embedding capture the meaning and capture all the essence of the phrase. But maybe you wanted to spot a particular thing, a particular knowledge article, and you have to be very specific. And here, the knowledge graphs and the other bag of words algorithms could work well or could assist better in fetching the correct knowledge articles, right?
Mhm. Yes. Mhm. Yes,
Okay.
definitely.
Okay, I think we are done with uh, the knowledge graph
Yes. Mhm.
presentation.
Yes.
Um, Thank you very much, Danny. Was awesome. It was
Thank you.
very beautiful and super easygoing. So,
Yes.
okay, thank you for joining, everyone. Okay, we were here. We will be here for the ninth episode. I expect that Fede or Juan Cruz will join us again. Now they were replaced by a GPT. I don't know where they are, but okay. But thank you for joining, everyone. Danny, it's all yours.
Okay. Thank you all. Thank you for watching. I'll be adding the Google Colab notebook on the comments, so you can check if you like. Thank you.
Bye bye.